This is the world's first self-assembled bio-based all-solid-state sodium battery, or the Bright battery as we call it. 10 years ago, when we launched the Bright initiative on safe and sustainable bio-derived batteries by design, I couldn't help thinking this is really ambitious.
Now, 10 years into Bright, we see products on the shelves in supermarkets and we see people at home doing fermentations to substitute meat in their own diets. This has a huge impact on the environment because basically these microbial foods are delicious and they're nutritious, and they also come with a much lower carbon footprint than many animal-derived foods. So we have a shift in our impacts of our diets.
We set out to use generative AI and machine learning to design entirely new amino acid-based polymers engineered to create perfect three-dimensional morphologies to facilitate fast ionic transport and structural integrity. Bio-based, durable, scalable.
Back in 2026, we thought that we just needed more data. Standing here today, 10 years later, what made the difference was a shift in how we think about proteins. Over the last decade, we have equipped microbes with such building blocks to produce chemicals and materials by recycling waste derived from greenhouse gases and synthetic polymers. We also learn to design biomaterials that are high-performing and self-healing, replacing pollutants harmful for our environment with eco-friendly proteins.
We have developed very efficient microbial cell factories and scalable fermentation process to allow the production to be cost-effective. After 10 years working in Bright, I'm very happy to see our protein-based product being used in sustainable agriculture or in industry for replacing petroleum-based polymers.
We've gotten there through a lot of fundamental research mapping genotype and ecologies with flavor and texture and nutritional value, and really enabling precise fermentation. And not only in industrially scalable versions of that, but also robust fermentations that can be done at home without a lot of infrastructure needs, that actually democratizes food fermentation also at home.
We expanded the search space to include non-canonical amino acids and learned the rules of assembly and how to produce at scale and at cost. And then we closed the loop, performing autonomous synthesis and characterization of the battery materials. And testing in a self-driving battery laboratory where we didn't just use the measurements, but performed active learning on the measurement data and the simulation data to improve the performance of the battery materials and cells. While these were breakthroughs in their respective fields, the biggest impact was the collected effort of the bright minds from different disciplines coming together on a mission to make the future a little brighter.